Calculating a standard deviation of a sample data set. We have the data set here. So let's go ahead, put it into our list. We can use L1, make sure you clear it out. And then we'll calculate the one variable statistics. Hit stat, enter for edit. And I already populated L1 with this data set. All right, I cleared it out and then put in this new data set. Hit stat, over to calc again, one variable statistics, just like the previous question. And this calculates the mean, it calculates the elements added up, the sum, it calculates the elements squared and then added up. And what we're looking for is the sigma x, because this is a sample data set. We're going to use the sigma x number 2.19, which is rounded to the nearest hundred. And that's where we're going to get over here. Now the variance of a data set is the standard deviation raised to the second power. And this is generally, if we're calculating by hand, the variance will come first, and then the standard deviation will be the square root of that. Since we're using a calculator, it's going to be the reverse. We'll find the standard deviation, then we'll raise it to the second power to find the variance. The standard deviation is the number that we are going to use and the number that is most used in real life. So identify which values cover 68%, 95%, and 99.7% of the data. So what a standard deviation does is it kind of measures how spread out the data set are, the data elements. Since the mean, the average, calculates the central location of the data, then that is going to be our middle. Our statistics tell us that our average up top is equal to 9. So that is going to be the middle of our data. And 68% of that data is going to be located within one standard deviation of the mean. That means 9 plus 2.19 and 9 minus 2.19. That's going to cover the values of 6.81 up to 11.19. 95% of the data is going to be covered within two standard deviations. So the same process, just now this 2.19 standard deviation number has to get multiplied by 2 in order to find the range of 95% of the data. So 4.62, which is the result of 9 minus 2 times 2.19, and 9 plus 2 times 2.19, to get an upper boundary of 13.38. 99.7% of the data is covered by the mean plus or minus 3 standard deviations. So 9 minus 3 times 2.19, order of operations means the multiplication, 3 times 2.19 comes first, and then it is subtracted from 9. That gets you 2.43. The same thing with the plus sign, gets you 15.57, and this covers 68% of the data, 95% of the data, and 99% of the data.